Hello guys, how are you doing? My name is Andrea Rivera and I'm going to talk you guys about the sustainability in concrete construction. So, as you guys know, sustainability is important to the well-being of our planet, continued growth of a society and the human development. Concrete is one of the most widely used construction materials in the world. However, the production of Portland cement, a constituent of concrete, leads to the release of significant amounts of CO2, a greenhouse gas, a greenhouse gas, a greenhouse gas. The production of one ton of Portland cement produces about 1 ton of CO2 and other greenhouse gases. The environmental issues associated with the greenhouse gases, in addition to natural resources issues, will play a leading role in the sustainable development of the cement and concrete industry during this century. For example, as the supply of good quality limestone to produce cement decreases, producing adequate amounts of Portland cement for construction will become more difficult. There is a possibility that when there is no more good quality limestone in a geographical region and thus no Portland cement, all the employment associated with the concrete industry, as well as new construction projects, will be terminated because of limited natural resources concerned over, over greenhouse gases, or both cement production is being curtailed or at least cannot be increased to keep up. With the population increase in some regions of the world, it is necessary to look for sustainable solutions for future concrete constructions. A sustainable concrete structure is constructed to ensure that the total environmental impact during its life cycle, including its use, will be minimal. Sustainable concrete should have a very low inherent energy requirement, be produced with little waste, be made from some of the most plentiful resources that we have on Earth, produce durable structures, have a very high thermal mass, and be made with recycled materials. That's the main goal. Sustainable constructions have a small impact on the environment. They use green materials, which have low energy costs, high durability, low maintenance requirements, and contain a large proportion of recycled or recyclable materials. Green materials also use less energy and resources and can lead to high performance cements. And concrete must keep evolving to satisfy the increasing of the population and the demanding rate of all its users. Designing for sustainability means accounting for the short-term and long-term environmental consequences in the design. As I mentioned before, cement is one of the world's most used building materials, right? With its production reaches about 4.3 billion tons per year in 2014, and it's growing 5% to 6% annually. Today, it is the responsible for 5.6% of the global carbon dioxide emissions and a major contributor to climate change. If the cement, that's a crazy fact that I found, that if the cement industry were a country, it will be the world's third largest emitter. To stay below 2 degrees Celsius of global warming, cement's carbon intensity must be reduced to near zero as soon as technically feasible. Fortunately, the right policies and technologies can make cement manufacturing a net climate benefit. During its lifetime and after demolition, cement naturally captures a significant fraction of the CO2 emitted during its manufacture. When this effect is combined with carbon capture and storage, the energy efficiency technologies and biofuels or electrification cement can remove more CO2 than it adds to the atmosphere. In the new book, Designing Climate Solutions, a policy guide to low carbon energy, it was identified a suite of policies such as carbon pricing, industry efficiency, or emission standards, and government research and development support to help ensure the necessary technologies exist and incentivize their use. Cement is a constituent of concrete, and 60% to 70% of its manufacturing emissions come from the breakdown of limestone into CO2 and lime. Most remaining CO2 emissions come from burning fuels, usually coal, to heat input materials. Preventing dangerous global warming levels requires reducing CO2 emissions to zero later this century. In fact, most scenarios that avoid dangerous global warming involve negative emissions, such as strategies for removing CO2 from the atmosphere in the late 21st century. The challenge is finding cost-effective technological approaches to carbon removal that work at a global scale. Because cement is already used in tremendous quantities worldwide, it is an overlooked and promising option for CO2 removal. Cement can remove CO2 from the atmosphere. After it's manufactured, the cement undergoes a carbonation process wherein concrete exposed to CO2 and humidity slowly bonds with the CO2, storing the carbon in mineral form. Because concrete is porous, CO2 slowly can diffuse into the concrete, carbonating the cement to a depth of 60 millimeters or more over a number of years. The policy is to reduce the CO2 from cement making. To make carbon negative cement possible, cement manufacturers must adopt new technologies. Several policies can provide incentives and assistance to industry, including carbon pricing, such as a carbon tax or a cap and trade systems that give cement makers financial incentives to install carbon capture equipment and other upgrades. Industrial Industrial energy efficiency or industrial process emission standards will help ensure all producers meet minimum requirements, shoring up the lagging producers or facilities. Government research and development support that drives down the costs of new technologies, including carbon capture, new biofuels, and novel techniques for electrical generation of the high temperatures used in cement making. We can see right here how the cement is made. I'm going to show you. Um, this is the factory where they make the cement, and this is the high. This is how they make it. They need a very high temperature in order to produce cement or and then concrete. Thank you very much for your attention. I hope it helps you a little bit. I hope it helps you to understand more uh, about the cement and concrete and its effects on uh, on global warming and how can we make it more sustainable. Have a great one. See you later.